Hello class. In this video we're going to answer question 1-1 on the problem set I gave you over the weekend. If you don't have that problem set, I'll post a link to it down in the description. Part A is actually very easy to do if you happen to remember this equation. If you don't, it's still doable, but it'll take some work. So let's see what we're given. From the problem we can see that the sled has an initial speed of 20 meters per second, a final speed of 5 meters per second, and travels a total distance of 20 meters. Since its acceleration is uniform the entire time, we can use its average speed, which we can find to be 12.5, to figure out how long it had to have been moving. If we do that math, we find out that it's 1.6 seconds. Now that we know the change of velocity and the time, we can easily plug that into the equation for acceleration, and find that the acceleration must be 9.4 meters per second squared. Part B gives us a new initial speed of 35 meters per second, and a total distance of 250 meters between where the sled starts and a wall. It asks at what time the brake must be pulled to keep the sled from hitting the wall. In order to do this, because we have a changing acceleration, the first part there's no acceleration, the second half is what we found in part A, we need to draw a velocity versus time graph. This should look like a horizontal line at 35 for when there is no acceleration, and a straight line going down to 0 after the brake is pulled. Because we know the change in the sled's velocity has to be 35 meters per second, and we've already calculated the rate of acceleration, we can figure out how much time it'll take the sled to stop from 35 meters per second. If we do that math out, we end up with 3.7 seconds. Once again, using the equation for average velocity, we can figure out that the sled must travel 64.8 meters during the time it's stopping. That means it has to travel 185.2 meters at whatever time it goes before we hit the brakes. Since that must be the area underneath the first part of the graph, which you'll notice forms a rectangle, we can fairly easily find the time it'll take. If you do the math out, we end up with a final answer of 5.3 seconds. And that's how you solve the first problem. Good luck with the others, and I'll see you on Monday.